Assalamualaikum warahmatullahi wabarakatuh. My name is Fadhil Aizat bin Rusyaidi, and I will be presenting about the company profile of Team Angstrom. Okay, about Angstrom. Angstrom Corporation Sdn Bhd is an up-and-coming company which specializes in artificial intelligence and machine learning. This is in conjunction with Industrial Revolution 4.0, which is the trend towards automation and data exchange in manufacturing technologies and processes, which includes cyber physical systems (CPS), the Internet of Things, Industrial Internet of Things, cloud computing, cognitive computing, and artificial intelligence. This company was founded by 5 friends in early 2020 before the spreading of COVID-19 virus. However, that did not stop them from developing their first and current project, which is known as Drowsy Driver Detector (DDDD). Okay, our company specializes in artificial intelligence and machine learning. However, our current focus is to use what we specialize in, making the transportation industry safer and easier to use, especially car. Our mission is to make everyday human activity easier and safer by increasing the safety feature of car or other transportation vehicle. Our vision is by increasing the safety mechanism of car, we believe that the deadly rate of death involving car accident can be reduced. Our values is we value the ideas and voice of every employee we had, therefore produce a productive and better problem solving team. Meet our outstanding team. The founder of Team Angstrom, which consists of 5 friends. Okay, more on them on the next page. Okay, this is the organizational chart of Team Angstrom. This team is led by me, Fadhil Aizat, as CEO slash project manager. Shafiq will be acting as finance slash hardware engineer. Atiq will be in charge of safety secretary slash software engineer. Our leader of software engineer is Rusyaidi. Our head of our engineer is Fadhil. Our current project is Drowsy Driver Detector (DDDD). And more on this project will be presented by my other teammates. Okay, the problem statement for the project is the rising of drunk and drowsy driving that leads to many accidents and injuries toward people in Malaysia. The objective is to improve road safety by detecting drunk and drowsy driving people in Malaysia, and to encourage people to practice a safe style of driving. The benefits of this project is the project is a proactive way of our company in reducing the rate of an accident involving drunk driver. The success of this project will definitely help reducing the number of family who lost their family members to drunk driver at Malaysia. The contribution. This product is a way of our company in contributing to our beloved country with the hope it can bring peace to family which their family members fall victim to drunk drivers and reducing the numbers of drunk related accidents.
Hi everyone. So right now I'm going to present to you the methodology for IDP1. So the first thing here is the experimental design. So we are going to we're going to connect the Raspberry Pi camera to the Raspberry Pi 3 Plus via camera port. Then we are going to interface it with the OpenCV module inside the Python script. So the figure 1 shows the arrangement how we're going to connect the camera to the Raspberry Pi. And then the second point is to transfer Arduino Uno board onto the breadboard and thereby convert it to the DIY PCB. Basically, the objective is to reduce the cost. So this is the figure on a schematic diagram how we're going to transfer Arduino Uno on the breadboard. So the third one is to interface the other sensors listed in the equipment material to the ATmega32AP. So figure 3 shows the one of the example, which is the heart rate sensor. So the next is experimental setup. So basically, we believe that our product is suitable for 4-wheel vehicles and above, such as car, bus, and others alike. So this is the experimental method. So you can see that this is the table that the performance index matrix that we are going to use for during the development of prototype. So you could see on here is the things to measure. There are 4 aspects, which is accuracy, speed of execution, the effectiveness towards the user, and the convenience. The reason why we used it because it could help us to gain insights of what should be focused or changed after each testing stage. So this is the equipment and material. You can see that on the left, the 5 points here, the main sensors or the main components that we are going to use. which is the heart rate to detect the heart rate sensor to detect the heart rate pulse. As we all know, if it less than 65 beats per minute is considered to be drowsy, drunk, or fatigue driving. The next is eye camera, which is to detect the eye tracing and facial positioning. If the eye is closed more than 3 seconds, basically saying that the driver is sleepy. And the push buttons with numbers. So there are 9 push buttons that we are going to use for the sequence recognition. So the user has to basically they are going to be a random sequence number given, and the user has to input the sequence correctly. So the number 4 is the light dependent resistor to detect whether the hands of the driver is on or away from the steering wheel. The number 5 is the Raspberry Pi 3B Plus and Arduino Nano as the central processing unit, the processor microcontroller. And you can see on the right here, on the right side of the slides, these are the overall list of the equipment materials. So I want to highlight it from number 12 to number 20. These are the components that we are going to use to transfer Arduino Uno on the breadboard. So moving to the block diagram, uh, you can see here is the heart rate, the real-time video, the camera, and this light dependent resistor as the inputs, and going to the inside the Atiq 32AP. So the T arrow here, like the T junction here, is whereby 3B plus and the Atiq 32AP communicates with each other by digital pin for the notification system. So this is the output containing buzzer and sequence detection system. So moving to the flowchart. So for our prototype, we are going to use the switch case. As we all know, it is much faster, and we could prioritize which conditions that we think the most critical. Like in our case, whenever the eye is closed is the most critical one, showing that the driver is fatigued or sleepy or drunk. So we'll get into the limitation of the design. The first thing is the eye detections. As we all know that it lacks accuracy and might require many tests need to be conducted to improve the accuracy of detection. And the real-time video processing for eye detection might have lag. And the thing, it might require adjustment to certain people. So it might require adjustment to certain people. So the second point is the wireless communication. Basically, basically the limitation is that for our notification system, it requires Wi-Fi. It requires the connection of Wi-Fi. Without it, the notification system is null. So the number 3, the sensitivity of LDR. During the night time, the LDR might be less sensitive because of the situation inside the car is dark. So the number 4 is the Raspberry Pi 3B Plus computing power. As we all know, the limited 1 gig RAM inside the Raspberry Pi might burns a lot. So it might causes a lot of lag towards the eye detection system. So the number 5 is the power source. As we all know, the Raspberry Pi 3 B Plus and the 80 Mega 32AP uses the same power source, and it might drains the power. So this is the issue that we are going to think that we have to solve in order to ensure that the power is not limited to supply for both Raspberry Pi 3 Plus and 80 Mega 32AP.
Prototype and simulation. So I will talk about the MCO is placed by national government. This is our limitation because our company need to make an online meeting. So online meeting is a good discussion method in deciding something regarding the project, but it is limited to the development of the project itself because all the materials needed is at our workplace. Second one is lack of materials. COVID-19 also affected our material supply because most of the material is imported from China due to the cheap cost, and we don't have any resource in developing a working prototype as for this moment. And the third one is simulation. To tackle our resource problem, we decide to first simulate every part in our product by using computer software. So more on this will be explained in the next part. The algorithm part. Step 1, we preload the deep facial landmark in the Python shell and retrain facial mark and 68 location coordinate on person face. There are various locations that could be mapped from this facial landmark, such as nose, mouth, teeth, and others. In our design, we are going to use only the coordinates that correspond to the location of the eyes for the eyes detection features to accept the time response. Next step is we execute the file, the script file. What we call is ear, a short form for ear aspect ratio. From the equation of ear, we could figure out whether the eyes of the user are open or closed. For example, the value of ear equals to 0 means that eyes of the user are closed. Otherwise, the ear should equal to any number when both eyes are open. So our plan is to calculate the duration of how long person closes his eyes by the help of this ear equation. The measurement of how long the person closes his eyes could be done by using the time function inside the Python itself. And so the figure shows the situation where eyes are open and closed with the ears value for the situation. You can see the difference when the eyes close. Software use Python integrated with OpenCV that is responsible for the eye detection, and this one also used for program the Raspberry Pi camera. Use it for digital communication and also to push notification in the Telegram. This Arduino IDE. We use it to program the heart rate sensor, LDR, and buzzer. And so interface the OLED display with push button for subsequent system. That's all from this part. And thank you.
Assalamualaikum and very good morning to everyone. My name is Muhammad Shafiq bin Muhammad Zulkarnain. Today I will be presenting about our financial proposal for our project. So for the first one is material costing. As we can see here, here is the list of the required material in order for us to build our project. Raspberry Pi 4 Model B will act as the brain of the project, and the overall price will be 681 ringgit and 60 cents. Apart from material cost, we also need to consider another cost, which is labor cost per product, overhead cost per product, office and asset depreciation. Adding all the costs, total cost needed, the total cost per product will be 5,711 ringgit and 60 cents. Now we jump into the projection sales. For year 1, each month we will be producing 30 units. So for year 1, the total unit that will be produced is 360 units. For year 2, each month will be 40 units. The total for year 2 is 480 units. As for year 3, each month we will be producing 50 units, and the total for year 3 will be 600 units. For year 4, each month we will be producing 62 units, and the total units for year 4 is 744 units. And lastly, for year 5, each month 69 units will be produced, and the total units will be 838 units for year 5. So the reason why the production for each year is different is because we have decided that from year 4 to year 5, we need to improve our product to make a R&D on it or a new innovation on it. in order for us to compete with other company. So that from year 4 to year 5, the increment is just 7 per month, because we assume that our product will be slightly drop in sales starting from year 4 to year 5. To summarize all the projection sales from year 1 to year 5, we have made a return of investment analysis from year 1 to year 5. So for the year 1, the ROI will be 2.41%. For year 2, the ROI is 5.66%. Year 3, it is 7.49%. And for year 4, it is 9.01%. And lastly, for year 5, it is 9.15%. We can see here that from year 1 to year 2 to year 3, the increment of ROI is significant. We can see it clearly. But for year 4 to year 5, the increment is only 0.14%. This happened because we have decided just now that total units produced per month from year 4 to year 5, the increment is only 7 units. So that's why our ROI from year 4 to year 5 is slightly low compared to year 1, year 2 and year 3. And now we go to the final part, which is the break-even analysis. As we can see here, in order for us to gain profit, we need to at least produce 27 units per month. And for 27 units, we will gain profit for 86 ringgit and 80 cents. This is including all the costs, which is the office, asset depreciation, overhead costs, labor costs, and also the material costs. And this is the analysis for monthly break-even. So the units that need to be produced is 27 units. Monthly revenue break-even will be 24,300 ringgit. This is just the estimation. Per unit revenue, we will be selling it for 900 ringgit. And per unit variable cost, it will be 711 ringgit and 60 cent. Estimated monthly cost will be 5,000 ringgit. This is actually the office and asset depreciation, which is 4,000 and 1,000. In total, it will be 5,000. Here we can see the graph. At 27, we will achieve the break-even. So in order for us to calculate the project break-even, we need first to consider the development cost. The labor will be 15,000 ringgit. Materials will be 2,000 ringgit. Prototype will be 711 ringgit and 60 cents. So the total development cost will be 17,711 ringgit and 60 cents. Here we can see the project break-even graph. The project will break even in between year 1 and year 2 at this point. And we can see here that the trend of net profit will be increased up to year 4, and from year 4 to year 5, the value will start to drop slightly. We can see that it dropped slightly here. Thus, we can conclude that our product have at least 4 years commercial value before the sales start to drop. Assalamualaikum and very good morning to everyone. My name is Muhammad Shafiq bin Muhammad Zulkarnain, and today I will present to you guys about our planning for our project. Basically, we divide it into 4 phases. The first one is planning phase, initiation phase, execution phase, and lastly is release to the manufacturer. For planning, initiation, and execution phase, we divide it into 4 parts. The first part for planning is identify team. Second one is determine partner. The third one is establish budget. And the fourth one is planning complete. As for initiation phase, the first one is marketing. The second one is engineering and manufacture. The third one is sales and product support. And the fourth one is field service. Continue to the execution phase. The first part is marketing. The second part is engineering and manufacturing. The third part is sales and product support. And the fourth part is prepare for the manufacture. And then we will go to the last phase, which is release to the manufacture. So now we continue into our progress. For phase 1, which is the planning phase, we allocate 30 days to it in order for us to identify team, determine partners, until establish launch budget. After finish 30 days, we will continue into the second phase, which is the initiation phase. For this phase, we allocate 60 days starting from kickoff product launch until the obtain approval for updated plan and budgets. After finishing all the parts in initiation phase, we will continue into the next phase. The third phase or execution phase, we also allocate 60 days for it, for us to complete all the tasks, which is starting from marketing until the prepare for manufacturing release. Moving to the last phase, which is the release to manufacture phase, we allocate 20 days to it, starting from manufacturing until product launching. In this phase, we certify our product to make sure that our product have a high quality and also reliable to user. In final quality review, we will conduct final quality review and also release information of the product. The information that will be released is specification of our product and also user manual. And then we will launch our product. So that's all from me. Thank you.
Hello, and this is this discussion for our Drowsy driver detector. For the analysis, based on the research finding, the project is plausible to be done. And all simulation-based finding is halted due to the pandemic and will continue at a further time. Our result is looked from a theoretical view because we cannot do any simulation-based and only a research-based. And from that, we can conclude that the DDD can perform the desired task using its software and machinery part. The dynamic between the two major points need to be smoothly operated to reduce the lag in real time. It is very important because the project involves the safety of life. So time constraint is intolerable and we have to reduce the lag. Next is our justification. Our justification for only making a research-based finding is because the project is halted and the resource for the prototype is unavailable at the moment. The prototype needs to be done at a later date in order to fully understand the device potential and weakness. The prototype-based investigation is needed to acquire the real-life characteristic of the device and will be done at a later time. Our conclusion is, given that the crisis of the COVID-19 pandemic has become a worldwide issue, the progress of the project has slowed down diminishingly. The project simulation base or prototype has been altered until further notice and will be and our base idea is still plausible and profitable for a market perspective. This is because given that the society today, the condition is now at a greater demand for safety product and will become more in the future. Thank you, and that's it from us.